So what we've got here is my Teensy Load thing. And the most noticeable feature is this huge heatsink. But apart from that, there's a terminal block to connect the device under test. That's a battery or a power supply that we're going to measure how much current it can provide. There's a sense resistor to measure the current that's being drained. And I chose a kind of funny looking sense resistor, mostly just because it looked funny. And then there's this FET that controls the amount of current that's being drained from the device under test. And the FET is controlled by a feedback loop that goes through an op amp in this quad op amp package, and the current and the voltage limit for this thing are set by a couple of DACs here, and they are driven by the Teensy, which hangs off under here. And so the DACs are fed by the Teensy, the I2C devices, and the Teensy sets the current that it wants the load to draw and a voltage limit, which is handled by a diode hidden down in here and another one of these op amps. And then the current is sensed, and the actual voltage provided by the device under test is sensed and buffered again by some of these op amps and read by the ADCs on the Teensy. So now I'm going to set it up and hopefully show you how it works. Okay, so what we got now is the Teensy Load, which is now connected to my PC with a USB cable that's connecting to the Teensy underneath. Got a little breadboard power supply that does 5 volts unregulated and 3.3 on this side. That's just connected to a normal kind of wall wart thing. And that's connected to the terminal block on the Teensy Load here. We've got a multimeter, and the probes of the multimeter are attached across the sense resistor here to give an independent measure of the voltage across that sense resistor, and so the current that the thing's drawing. And then this thing, this little window, is one of the user interfaces that I've made for this thing. So this is a bit of Python GTK stuff that talks over the USB serial with the Teensy, and they've got a little protocol that this thing can use to set the to set the current and to the voltage limits and things like that. So anyway, let's set the voltage limit to 6 volts. The power supply is 5 volts. Let's set the current draw to 50 milliamps. Let's set some of this stuff up so that it'll take 10 samples per second, and for display it'll smooth 10 of them. It just prevents the wibbling around too much here. And we'll switch it on. Now, the power supply is not switched on at the moment. I'll switch the multimeter on as well. So there's basically no current flowing because the device under test is switched off. If I now switch on the device under test, and find the switch. Where's it go? Which way does it go? There we go. So now this thing says it's drawing 56, 57, 58 milliamps. The voltage is a little bit less than 5 volts. Now this is a bit difficult because the multimeter shows 0.5 millivolts across that sense resistor, and the sense resistor is really little. It's 0.4 ohms. So the accuracy of the multimeter is going to be a problem here. But what we can do is we can look at what happens as we change it. So let's increase the current draw from 50 milliamps to 100 milliamps, like that, and we see that the current. So this is the current measured by the Teensy's ADC by looking at the voltage across the sense resistor, and on the multimeter we see that the sense voltage has gone up to 1 millivolt as well. So now this is completely uncalibrated. I should write some calibration software, and I should do this properly. But it's quite pleasing to see that it actually does work a bit. And there's, I mean, it's not getting warm now, but I don't know what this power supply will do. But let's see if we can get it up to, I don't know, 250 milliamps. I should have looked at the wall wart to see what it can do. So it's doing that with no problem. Let's try being ambitious. Let's put it up to 0.5 amp. Okay, so it's managing 0.5 amp. It's not getting warm at all. You can see that the multimeter's gone up to 4.8 millivolts, which is about what you'd expect. Let's be really ambitious and try for an amp, because I'm expecting, oh no, it manages an amp. So it's an amp at 5 volts. So this thing should be dissipating 5 watts. Oh, it's not getting very hot yet. Oh, maybe it's getting a little bit warm now. Let's try 1.5 amps. Go on. 1.5 amps. And now you see that the supply voltage is going down a little bit. It's not very good wall wart. Well, I don't know. I'm tempted to put it up to, let's try 2. 2 amps. Oh, and something went wrong in my code then. Oh, something went wrong. Okay, there's a bug, but it's all working partially. Let me put it back to 1.5. Can you go up a bit? Nope, I didn't like it up there. So 1.66 is okay. Oh, the heatsink's definitely getting warm now. So my worry was always that just absolutely nothing was happening at all. So it's kind of doing the thing. I can show you another thing now. If I so the voltage is 4 and a bit volts. If I set the voltage limit to 4 volts, then it should basically switch off and completely clamp the current right away. Oh, and it didn't. There's another bug. Oh God, live testing, don't you hate it? Okay, but that's what it does. It's the Teensy Load. It's a programmable load with a Teensy. It obviously, I don't know whether that's a software problem or a hardware problem, but it doesn't quite work perfectly yet. But it works a bit. It works a bit more than I thought it was working, so I'm pleased with that.